Assalamualaikum warahmatullahi wabarakatuh and greetings. I am Nadiah Farhani, binti Kamsin from Department of Civil Engineering, Faculty of Engineering, Universiti Pertahanan Nasional Malaysia. My supervisor is Dr. Zuliziana binti Suif, and I will be presenting on my final year project with the title of Surface Erosion and Sediment Yield Estimation using GIS. Erosion is a natural process where soil particles are displaced from the soil surface or depth. Human activities such as unrestricted land use, deforestation, excessive grazing, and climate variations contribute to accelerated soil erosion. Next, sediment yield measures the amount of sediment per unit area transported from a watershed within a specific time frame, reflecting the level of geomorphic activity. Soil particles displaced by erosive agents transform into sediment during the early stage of sediment transport. For the Geographical Information System or GIS technology, it collects, stores, presents, and analyzes spatial data. One of the most serious threats to ecosystem stability and attracting enormous societal and political attention. While high sedimentation can reduce storage capacity, which can lead to a variety of issues in the ecological, social, and economic spheres, such as lack of water for household, industrial, and agricultural usage. Development in the UPNM area contributes to soil erosion, blocking drains, and causing flooding during the rainy season, which affects the productivity of staff and students. For the study area, the Universiti Pertahanan Nasional Malaysia (UPNM) is situated in the Federal Territory of Kuala Lumpur, Malaysia, with the area of 235 hectares. The university enjoys a tropical rainforest climate characterized by high humidity levels throughout the year. The temperature in the study area remains relatively consistent, with the region experiencing common thunderstorms and heavy showers. The climate encompasses a combination of heat, humidity, and frequent rainfall. The significance of this final year project, where the result of the study will provide soil erosion mapping that will assist UPNM management in locating area with high risk of soil erosion. By using the results, management can take better preventative measures in areas that are more vulnerable to soil erosion and sediment yield, particularly during the rainy season. The study will encompass two primary components, which are data preparation and simulation work. The data collection process will be meticulously planned to ensure the acquisition of all necessary information. Notably, field data collection is not required since the study will heavily rely on pre-existing data and databases, such as the comprehensive USGS database. The study consists of running simulation using ArcGIS to determine the surface erosion and sediment yield in the UPNM catchment. All the data used is from 2016 and 2021. Then, the output from these 2 years will be compared. The study combined 5 factors of Russell model as an input parameter into raster calculator in ArcGIS to determine the soil erosion. The parameters consist of rainfall erosivity factor, soil erodibility factor, the slope length and slope steepness factor, crop management factor, and the conservation practice in raster format. The SDR is used to estimate the amount of sediment at the point of discharge. Figure shows the occurrence of potentially hazardous regions prone to soil erosion within the UPNM catchment. These locations are spatially concentrated in areas with steep slopes, inadequate support practices, and shallow soils. The spatial constraint of these vulnerable zones highlight the importance of targeted conservation efforts to mitigate erosion risk. There are significant differences in the annual rate of soil loss between 2016 and 2021. Changes in land use, climate patterns, and human activities could all have contributed to the observed variances in soil erosion rates throughout the defined time frame. This map classifies the locations into several groups depending on their sensitivity to soil erosion, which ranges from very low to low, moderate, high, and even very high. The map, by clearly delineating these different levels, acts as a significant resource for identifying priority regions that require prompt attention and intervention to effectively manage erosion concerns. According to the data, the estimated annual soil loss in 2016 was around 1.538 tonne per hectare per year, while it decreased to 0.9437 tonne per hectare per year in 2021. These estimates provide useful information about the erosive potential and variations in soil loss dynamics throughout the specified time period. Remarkably, the study found that the extent of erosion is predominantly determined by two key factors, which are terrain and vegetation cover. These elements are crucial in influencing erosion pattern in the UPNM region by the interaction of topographic features, vegetation type, and surface runoff erosion. Considering the figures, which show the spatial distribution of sediment yield divided into 5 unit groups based on their proportion of distribution, it is clear how important these elements are in influencing sediment yield distribution. The information in these figures provides crucial details about the dynamics of sediment production in the study area. The annual sediment yield concentration in the UPNM region is predicted to be approximately 0.5324 tonne per hectare per year in 2016, decreasing to 0.3278 tonne per hectare per year in 2021. These findings highlight the changing character of sediment output over time and emphasize the need of understanding the underlying mechanisms that cause these fluctuations. The distribution of sediment yield across the entire region exhibits a regular pattern that closely matches the distribution of soil erosion. It is clear that the locations with the highest levels of soil erosion also have a corresponding deposition of eroded sediment. The reciprocal relationship of soil erosion and sediment deposition illustrates the dynamic nature of erosional processes and their geographical implications. For the conclusion, the study estimates a rate of annual soil loss of roughly 1.5328 tonne per hectare per year in 2016, emphasizing the region's substantial erosion susceptibility during that time period. In the same year, the sediment production was calculated to be roughly 0.5324 tonne per hectare per year, reflecting the amount of eroded material carried and deposited within the watershed. The study finds a substantially reduced annual soil loss rate of 0.9437 tonne per hectare per year in 2021, indicating a potential improvement in erosion management efforts. The sediment yield for 2021 is estimated to be 0.3278 tonne per hectare per year, suggesting a decrease in the amount of degraded material carried and deposited. The expansion of the region impacted by surface erosion demonstrates the impact of rising development. The vulnerability of land to erosion increases proportionally as human activities intensify and urbanization advance. Nonetheless, despite this spike in development activity, the UPNM management proactive strategy has generated noteworthy accomplishments in mitigating the negative consequences of erosion.
That's all from me. Thank you.